us discuss the applications of trigonometry. Think of a situation where you're in front of a huge building like Eiffel Tower in Paris, which is the world icon. How would you measure the height of the tower? Would you just go to the top of the building and then drop a rope and measure the length of the rope? It's not convenient, right? Now, think of a railway bridge crossing the river. How would you measure the width of the river? You have to stand on the opposite banks of the river with a long rope or measuring tape, which is even more harder. It's practically quite hard, isn't it? Yes. If you know trigonometry, it's going to be much easier. Let us see how to apply trigonometry to measure the heights and distances. To take a step forward to the applications of trigonometry, one must remember the trigonometric ratios and their special angles as well. Let us quickly revise the basics of trigonometry. Let's consider a right-angled triangle ABC as shown in the figure. Now, from the triangle we see that side BC is opposite to angle A. This side faces angle A and is called as the side opposite to angle A in the triangle. AC is the hypotenuse of the triangle, as that is the longest side of the right-angled triangle. And the side adjacent to angle A is AB, which can be called as the side adjacent to angle A. Now, let us define the ratio of the sides of a right-angled triangle, which is called the trigonometric ratios. Side opposite to the angle A by hypotenuse is called the sine of the right-angled triangle, which is equal to BC by AC. Side adjacent to angle A by hypotenuse is called the cosine, which is AB by AC. Side opposite to angle A by side adjacent to angle A is called the tan, which is BC by AB. Now, let us reciprocate the ratios of sine, cos and tan. Reciprocal of sine is called the cosecant of the right-angled triangle, which is hypotenuse by side opposite to angle A, which is AC by BC. Similarly, reciprocal of cosine is secant of the right-angled triangle, which is hypotenuse by side adjacent to angle A, which is AC by AB. And reciprocal of tangent is cotangent of the right-angled triangle, which is side adjacent to angle A by side opposite to angle A, which is AB by BC. Let us see how to use these trigonometric ratios to find the heights and distances without even measuring them. Let's say we are standing in front of Eiffel Tower or any other building. Say that AB is the height of the tower and I am going to observe this building from a point C. And this point is called the point of observation. And if I join the line A to C, this line is called the line of sight. Thus, the line of the sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. Now, let us join C to the base of the building, that is B. As you observe, the angle between AB and BC is 90 degrees, as the building is standing perpendicular to the ground. Angle ACB is called the angle of elevation, which is represented by theta. The angle of elevation of the point viewed is the angle formed by the line of sight with the horizontal when the point being viewed is above the horizontal level. Consider this instance, where a person is looking down at a car parked in the parking area. In this case, the line of sight is below the horizontal level. The angle so formed by the line of sight with the horizontal is called the angle of depression. Thus, the angle of depression of a point on the object being viewed is the angle formed by the line of sight with the horizontal when the point is below the horizontal level. That is, in this case, when we lower our head to look at the point being viewed. Let's say, instead of Eiffel Tower, it was Leaning Tower of Pisa. Would the angle be 90 degrees between the base and the building? No. You can apply this concept only for the buildings which stand straight. How would you measure the angle with respect to the building? Surveying instrument, which is called as theodolite, is based on the principle of trigonometry, which is used for measuring angles with a rotating telescope. The first image what you see is the non-digital theodolite, which is rarely used and are now on display in the Museum of the Survey of India in Dehradun. The second image is the digital theodolites, which has an electronic readout screen to display the horizontal and vertical angles, which is extensively used in today's world. Trigonometry was invented because its need arose in astronomy. Since then, the astronomers have used it to calculate the distances from the Earth to the planets and stars. Trigonometry was also used in geography and in navigation. The knowledge of trigonometry is used to construct maps, determine the position of an island in relation to its longitudes and latitudes. Now, let's say BC was 100 meter and angle BCA is 60 degree. To find the height of any building, you need to at least know these two informations. That is, the distance at which a person is standing from the foot of the building, the angle of elevation and the height of the person. Let us see how to make use of trigonometric ratios to measure the height of the Eiffel Tower without even going to the top of the building. Now, let's neatly draw the diagram. Here, angle AB is the height of the building which is perpendicular to the base. So, here we need to find the height AB, therefore let us mark it as x. Now, a simple trick to find the height of AB is that take the ratios of unknown side and known side, that is AB by BC, which is equal to x by 100. From the trigonometric ratios, we know that opposite by adjacent gives us tan theta. Therefore, we mark AB by BC as tan theta. Also, the value of theta here is 60 degree with respect to the question. Therefore, x divided by 100 is equal to tan 60 degree. We write the value of tan 60, that is root of 3. Rearranging to find x, we get x is equal to 100 multiplied by root 3, which is equal to 100 root 3 or 173.2. Therefore, height of the building x is equal to 173.2 meters. Now, let's summarize. The line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. The angle of elevation of an object viewed is the angle formed by the line of sight with the horizontal when it is above the horizontal level. That is the case when we raise our head to look at the object. The angle of depression of an object viewed is the angle formed by the line of sight with the horizontal when it is below the horizontal level. That is the case when we lower our head to look at the object. The height or length of an object or the distance between two distant objects can be determined with the help of trigonometric ratios.